All right, concept E is going to combine a bunch of the concepts that we've actually done already. We're going to be talking in terms of percent compositions, empirical formulas, and also using how to convert from grams to moles. So we can use our percent compositions to find our empirical formulas. So for example, we can determine the empirical formula if we know that it contains 50% sulfur and 50% oxygen by mass. So how do we go about solving this? We're basically going to assume that this substance is out of 100 grams. And by doing so, we can simply take our percentages and change them to grams. So we're going to start with 50 grams of sulfur and 50 grams of oxygen. Then we're going to go ahead and find the moles of each. So I'm going to first convert 50 grams of sulfur to moles of sulfur by using the gram formula, mass, and dimensional analysis that we've done in a previous concept. So I find that I get 1.56 moles of sulfur. I can then go ahead and do the same steps with oxygen using oxygen's gram formula mass. So now that I have these two moles, I can look at it in terms of this formula. So remember, when we use our subscripts, we can look at them in terms of moles, and we do have 1.56 moles of sulfur and 3.125 moles of oxygen. However, we don't usually see chemical formulas written like this. We want whole numbers. So how do we go about doing that? We're simply going to divide each by the smaller of the two numbers. Basically, that's setting us up so that one of those subscripts, is equal to 1, and then we'll see how the other ones fall. So here we have then S1O2. Or SO2. Now sometimes you may find that once you divide by the smallest, one of your numbers may end in 0.5. That simply means you're going to multiply both or all of the numbers by 2. And we'll see some of those examples in class tomorrow. Alright, we're going to go through the second and last example so you can get a better idea about how we're going to be calculating again this empirical formula. I'm using the same set of steps, so I'll remind you of those as we go. So we have lithium, carbon, and oxygen. We're going to assume that they're out of 100 grams. So we're then going to write that we have 18.7 grams of lithium, 16.3 grams of carbon, and 65.0 grams of oxygen. We're then going to convert each of them to moles. So you need to find their gram formula masses off of the periodic table. So lithium is 6.9 grams, so that's going to be equal to 2.7101 moles. We're then going to convert carbon to 1.358 moles and oxygen to 4.065 moles. So once you have them all in moles, this is when we're going to divide by the smallest. So since 1.358 is the smallest, I'm going to divide by that for all of our moles. So we then find that we have 2 lithium for every 1 carbon and 3 oxygen. So those become our subscripts. So our final answer is we do have Li2C1O3. All right, we'll practice a lot more tomorrow. I know this is a little bit confusing because there's a couple of steps that you need to keep in mind. So just bring your questions and just remember to go online and complete your summary. I would specifically focus on the steps and being able to verbalize and write how to explain to these calculations in your own words.